question.
Okay. So for this first one, number one just says, use the data in the table. Well, first of all, the density of bacteria population in a circular petri dish at a distance r centimeters from the center of the dish is given by the increasing differentiable function f, where f of r is measured in milligrams per square centimeters. So the further you get away from the center, the more dense the bacteria become. Values of f of r for selected values of r are given in the table above. Okay, so for the first thing you want you to do is just to estimate f prime of 2.25. So how do you do that? Let me reproduce the table here. So we have r, f of r. Hopefully you guys haven't forgotten everything. Other than that long. 0, 1, 2, 2.5, and 4. And then 1, 2, 6, and 18. So how do you estimate f prime of 2.25? Yeah, you just take the points that are on either side of it, which would be these 2 points, and then just do the average rate of change, right? Which is just the slope formula. So for part A, you should have just done f of 2.5 minus f of 2 divided by 2.5 minus 2. So this is 10 minus 6 over 0.5. And this is approximately f prime of 2.25. And you can leave it just like that. Any questions on that? Raise your hand if you think you did that. That's a good start. Okay. Part B.
Wait.
Oh, interpret. Oh, sorry. Okay. Interpret the meaning of your answer in the context of this problem. Oh, so what would the units be? Oh, okay. Well, now, okay, maybe this question wasn't so easy. What are units? If the units for f of r are milligrams per square centimeter, then what would be the derivative of that units?
That's it for unit of time, but I don't think that's good. They didn't give a unit of time.
Yeah, they don't talk about time at all.
Milligrams per square centimeter per centimeter.
That's what it would be,
Yeah.
right? The independent variable here is centimeters. So whatever the units of the y-axis value are, it's the derivative would be per centimeter. So it's going to be milligrams per square centimeter per centimeter. That's correct. That's confusing. So it's milligrams per square centimeter per centimeter, like that. And what would be the meaning of this? Like, what does this number actually mean?
Like 2.25 centimeters, the bacteria population is increasing. Whatever that value is.
Yeah, it's kind of like the rate of change, but rate implies time. Oh, this is confusing.
Yeah.
Yeah, this is weird. Hopefully you didn't sit there and like ponder this for too long.
I didn't realize it was confusing until.
So, like I would say that this was probably a 2-point question, 1 point for getting the correct value, and 1 point for the explanation with units. So if you didn't get the explanation with units, it's not the end of the world. That means that the most you could have gotten on the rest of the free response was 53 out of 54. That's okay. That's still a 5.
Wait, you don't have any of those. They didn't give out an answer to that.
What's that?
They didn't give out like the answer to it.
No, there's no like grading rubric yet. So, I mean, what I would have written here is I would have said kind of what Bella said, but it's a little, I'm not 100% confident in that just because when you talk about rate of change, it implies that there's time involved, and it doesn't say anything in this problem about time. It's more like, it's not like as time elapses, it's as you go from center to the outside. So it's a little bit, I don't know if rate is the right word, but that's So I'm not quite sure what I would write precisely, but something like what she said would be probably more credit. Okay, part B, it says the total mass in milligrams of bacteria in the petri dish is given by this integral expression. 2 pi integral 0 to 4 of r times r dr. It says to approximate this using a right Riemann sum with the 4 subintervals indicated by the data in the table. This question was really weird. I've never really seen a question like this on an AP test because it's not a topic that's supposed to be tested on the AP test. It used to be. It's a topic called the method of cylindrical shells. So let me just give you a thing here. So if I look up method of cylindrical shells, this is just a random page that I just Googled. So the cylindrical shell method, you can see it's the integral of 2 pi x f of x dx. And that's exactly what we have here. We have the integral of 2 pi r f of r dr. It's the same thing, right? So let me just explain briefly what the method of cylindrical shells is. And by the way, if I Google further, like if I Google and say, are cylindrical shells on AP Calculus AB? I don't want you to think I didn't teach you something I was supposed to teach you. Is the shell method on the AP Calculus exam? It says, there are no places on the AP test in which you have to apply the shell method, according to the College Board. However, the shell method can save you time, so it's good to know. So,
So can we write to the College Board and be like,
well, technically, they didn't require you to know the shell method because they kind of gave it to you and didn't say what it was. But I still think it's a little bit of a cheap shot, and this question, I think, is a little bit unfair because it's not on the curriculum. But let's just talk about it, and we'll just move on. Like you should have if you did this problem. Like just make your best effort at it and just move on. All right. But here's how the method of cylindrical shells works. If you have a function like, suppose you have a region like that's shaped like this, and you want to rotate it around the y-axis, and we have the equation of this parabola in terms of x. Now, normally, when you rotate around the y-axis, you're thinking, well, I must have y values as limits of integration, and I have to have functions of y as my like radii. In this case, it would be like in the washer method, right? So you're thinking, in a typical problem like this, you're thinking, well, a typical cross section would be like this. If I rotate it around, I get washers. So I would just need to find like the volume of a typical washer and then integrate it over the whole interval, right? But what the shell method does is it gives you a way to keep functions of x even though you're rotating around the y-axis. And the way that works is you would take like this little thin rectangle and rotate that around the y-axis. So what you would end up with would be like a cylinder that has just a little bit of thickness. Does that make sense? You'd have these cylinders where you have a little bit of thickness. So if you're trying to calculate a volume, like for example, well, let me just draw a picture, see if this comes out okay. But maybe it might be like a cylinder that looks like this, right? A cylinder that looks like this, and then there's another cylinder like next to it that kind of looks like that, and then there's a cylinder next to it that looks like that. So let's just suppose that this function was decreasing from inside to outside. There's this innermost cylinder that you can picture going all the way to the bottom, and then there's the next layer that you can picture going all the way to the bottom, and then there's this bigger cylinder that goes all the way to the bottom. If you took all three of these cylinders and like open them up, a typical cylinder, like they call it cylindrical shell, because it has a little bit of thickness. If you take a cylinder that has a little bit of thickness like this, and you cut it and unroll it, it's going to look like this, right? It's going to be like a rectangle that has a little bit of thickness. It's going to kind of look like that. Do you agree? This distance is going to be 2 pi r, or 2 pi x, right? This distance is going to be like f of x. And the thickness is going to be like the dx, or the delta x, the change in x, right? So the volume of material, or whatever it is that you have in this rectangle, is length times width times height, which is 2 pi x f of x dx, right? Well, if the volume in this rectangular prism is 2 pi x f of x dx, then the volume in this little shell is also 2 pi f of x dx, right? And if you take thinner and thinner and thinner shells, that's like what integration is. It's like taking a summation and just taking infinitely many of them. So it's like the same process that we did when we did Riemann sums. If you take thinner and thinner rectangles, you get a better estimate. Same thing here. If you take thinner and thinner cylindrical shells, you get a better estimate of the actual volume. Does everybody understand the concept? And it just makes it so that, like, especially in a situation like this, if this was a function of x, like say this was y equals x squared minus 2x. I mean, that's a really easy function of x. But if you tried to solve this for x to get a function of y, it would be complicated because there'd be two y's, and one of them would be squared and one of them wouldn't be squared. You'd have to do like some crazy like quadratic formula thing, and you'd get a plus or a minus, and this part would be the plus and that part would be the minus, and it would be really wacky. So this one, it would be much more convenient to just keep it as a function of x. Keep it as a function of x and do the shell method instead of making a function of y and trying to do the washer method. Do you see the benefit? This method was on the AP test for years and years, and they stopped it in like 2010. And they said, okay, we're not going to require anybody in AP Calculus AB to do the shell method anymore. We're just only going to have problems that use washers and disks. So sometimes like in the intervening years, I've taught the topic just like as a quick little thing. And sometimes I haven't, and I didn't this year, and I totally apologize for that. But anyway, let's get back to this problem. So this problem, the bacteria kind of look like this, except the opposite, right? So the innermost cylinder is like the shortest. Then the next one's a little bit taller. Then the next one's a little bit taller. It's just hard to draw that so that you can actually see what's going on. But can you kind of picture the situation? Okay, so if you're trying to calculate or estimate this volume using a right Riemann sum of cylindrical shells, which is like mind-blowing. I've never really seen a problem like that. But if you kind of picture what that situation might look like, it's just like what I described. So if I have this table, if I'm using the right endpoint as like the height of each of these cylindrical shells, I also need to know like what's the distance between the x value, the r values, right? So this distance is 1, this distance is 1, this distance is 0.5, and this distance is 1.5, right? So if I just think about what I'm doing in terms of these rectangular prisms, like if I'm just summing up these rectangular prisms where this distance is given by the right endpoint, then I can do this like without too much trouble, but it does require like some concentration. Like if you think about it, what I'm really going to do is I'm going to take, this is going to equal approximately, the 2 pi is just, you can leave it out front because it's just a constant, just like they did. So I'm going to have the first rectangular prism is going to be 2 pi r, which is 1, times f of r, which is 2, right? It's using the right-hand endpoint, times the thickness of the little rectangular prism, which is 1. And then the next one is going to be 2 pi r, which is 2, times f of r, 6, times the thickness, which is 1. Then the next one's going to be 2 pi r, which is 2.5, times f of r, 10, times the thickness, which is 0.5. And the fourth one is going to be 2 pi r, which is 4, times the height, 18, times the thickness, which is 1.5. That's the answer that they wanted in this problem. I know it's confusing because you're tempted to just do r times f of r each time and not include that last part. How many of you did that? That's what I think would be the biggest, the most common wrong answer. How many of you think you might have done this right?
I don't really remember what I thought.
You're not quite sure? Okay, so, I mean, the good news is if this was a 2 or a 3 point question, if you did some kind of remod stuff, like say you forgot the 1, 0.5, and 1.5, you might have gotten 1 out of 2 or 1 out of 3 or 2 out of 3. And it is what it is, and you just move on, and that's all there is to it. I mean, but does this make sense, like the way I've done it here? I wish I'd given you guys an example, because I know you definitely would have been able to handle this process, but I didn't even think that it was a possibility, like that would be on there. So anyway, sorry about that. Let's move on. Part C. Part C says, is the approximation found in part A an overestimate or an underestimate? So what do you think here? Yeah, I think it's an overestimate because back to my model here, again, this is a little weird because this is like a descending, this is a decreasing function. But if it was an increasing function, like you'd have like, hard to draw, but you'd have like the first outermost ring would be here, right? And then it would dip down, say this was just the outermost ring, okay? The function itself is actually, that's the high point. It goes down from there on the inside. You can sort of picture that. And then the next ring down, it's the same idea. The outermost radius is like on the function, and the innermost radius is definitely like below the function, right? Or it's below the function is below the rim of the cylindrical shell. So yeah, this is an overestimate. And if you just wrote, it's an overestimate because f of r is strictly decreasing or increasing, I'm sure that's full credit. So for that question. Okay, so the answer is overestimate. With a short little explanation. All right, D. This says the density of bacteria in the petri dish is modeled by the function. I haven't even read this part, so this is g of r equals 2 minus 16 times cosine of 1.57 radical r cubed. So before I do anything, I'm just going to type it into my calculator because this is a calculator question, and I'm sure I'm going to have to use it. Okay. Plus, that way, if I run out of time, I can still do it, but the calculator take away, so forget that. All right, so this would be 2 minus 16 times cosine of 1.57 radical x, close parentheses, squared, or cubed. All right, let me make sure I have enough parentheses here. I don't. All right, so I need parentheses around this. Okay. All right, so insert parentheses. All right, then just make sure there's no typos at all, and then enter. Okay, so now the question says, for what value of k, between 1 and 4, is g of k equal to the average value of g of r? Okay, so that's not too hard, right? So the average value of g of r on the interval from 1 to 4, that's 1/3 times the integral from 1 to 4 g of r. Right? That's the number we're looking for. So I just want to know when this equals g of r. C or whatever they call it. Okay. That's all I want to know. So all I'm going to do is I'm going to take this integral, find its value, Then I'm going to graph that as a separate function, y equals that horizontal line, and then just see where they intersect. It's that simple. Did everybody do that? You want me to do it, or we're good to go on to the next problem? Okay. So, I mean, just thinking about this question, I think that the ones that were probably hard were the explanation in part A and doing this correctly. So even if you had totally messed those parts up, I would say that that's probably like maybe 5 out of the 9 points, and you could still get 4. But hopefully you got some partial credit up here, like for this value, and maybe you did some sort of Riemann sum here. Maybe you got the units right and got that, or whatever. Okay, so this was a hard question. I bet when the statistics come out on this test, this was probably the hardest question. I haven't seen the other questions. Maybe I'm wrong.
Yeah.
I'm wrong? Okay. All right, I haven't seen them, so here we go. All right, so far, this is a really hard test. Number 2.
Yeah.
Number 2. Okay. Particle P is moving along the x-axis. The velocity is given by blah, blah, blah. At time 0, particle P is at position x equals 5. So I'm just going to write that down. So I'm going to say x P of 0 equals 5. That's the information they're giving us, right? Then they're saying a second particle also moves along the x-axis. Its velocity is given by that. At time t equals 0, the particle q, so I'm going to write the same information. The position of q at time 0 equals 10. And then I'm going to actually type these into my calculator. Before I even read anything else, I'm going to make sure everything's good to go. So v of p of t, is sine of t to the 1.5 power. T raised to the 1.5 power. Leave that. See there. Okay. So that's the first velocity. And the second velocity is parentheses t minus 1.8 times 1.25 to the t. So those functions weren't that complicated to type, but again, just make sure you don't have any mistakes. Make sure your calculator's in radians and all that stuff. Okay, now I'm all good to go. So for part A, it says find the positions of particles P and Q at time t equals 1. So this is just FTC part 1, twice. That's it. So the position at time 1 for P is the position at time 0. The notation is like the hardest part of this problem. So it would be the position at time 0 plus the integral 0 to 1 of Vp of t dt. That's all you have to write, and then just give an answer. And for x q of t of 1, it's the same thing. It's just x q of 0 plus the integral from 0 to 1 vq of t dt. And then give an answer. So for the first one, you can do this really quickly. The first one is just going to be 5 plus math 9 from 0 to 1 of function 1 dx. Done. 5.371. For the second one, it's 10 plus the integral, math 9, from 0 to 1 of function 2 dx. 8.564. That's it. That would be full credit. That would be full credit. Okay. Part B, it says, are particles P and Q moving toward each other or away from each other at time t equals 1? How could you answer that? And then, like, how would you know if they're moving toward each other, for example? If you calculate the values of the velocities. Like, what's going to tell you that they're moving toward each other?
This one.
Yeah, just opposites. Well, not necessarily even opposite signs. It looks like P, the velocity of P would have to be positive, because if you look at on a number line, P's here and Q's here, right? So P would have to be positive and Q would have to be negative in order for them to be moving toward each other, right? Yeah. That's what I'm just thinking. What if P is moving really quickly and Q is moving really slowly that direction? They're still moving toward each other, aren't they? So okay, so we need more information. Let's just find the values. So for part B, you just need to find BP of 1 and BQ of 1. That's easy. That's just using the value thing on your calculator, right? So if I just do, if I graph these from 0 to pi, because that's what these functions are good for, right? From 0 to pi. So if I go to window, 0 to pi, and then zoom fit, there's 2 functions, and I go second calc value at x equals 1. Okay, so the first function has a value of 0.841, 0.841, and the second one, all I need to do is just press the down arrow. It's -1. Okay, so we don't have to worry about that situation. That would have been a little bit more confusing. If this is moving quickly and this is moving slowly, like they're moving towards each other. Like generally the distance is getting shorter. So that would have been a little bit more confusing. But in this case, P's going this way, Q's going that way. They're definitely moving towards each other at 1. And you could just say, since this is positive and this is negative, they're moving towards each other. That's all you have to say, really.
You have to explain that x of q at 1 is.
That would probably be safer. If you said P is to the left of Q and VP is positive, so it's moving to the right. BQ is negative, so it's moving to the left, so they're moving towards each other. Something like that.
I think I wrote a whole pair.
Yeah, just to be safe. I mean, it doesn't hurt, but it does take time. So there's a trade-off there, right? Part C says, find the acceleration of Q at time t equals 1. So that would just be the prime of Q at 1. That's all you have to do is just say that, right? So that would be second calc dy dx at 1. And this is P, so Q would be this function. And the value, did I mess up?
Yeah, I think we just have to do it again.
Second calc dy dx at 1.
That's for the first one, that's one.
Yeah.
Is that how it works? Second calc dy dx. Did anybody get messed up by that? Oh, just me? Okay. So this should be 1.027. I think that's a little confusing. 1.027. What I would have done, I would have tried it a couple times, and I'm not that smart with technology, so I would have just gone to this screen and just been like math 8 dy dx of function 2. Oh,
Yeah.
you all saw that happening. Nobody said a word. Damn you. Function 2, and then at 1. That's what I would have done probably.
That's what I did.
Okay, so you were confused. Because otherwise, that's not the easiest way to do it. The easiest way to do it is from the graph, for sure. But if I got confused and I'm like, this is not working the way I hoped it would, then I would have just like, to save time, do it the longer way, which sounds ironic, but that's true. It says, is the speed of particle Q increasing or decreasing at t equals 1? What's the answer? Is the speed increasing or decreasing at 1? How do you know? Yes, okay, so the novice here, the noob, would say, since the acceleration is positive, it must be speeding up. That's not true, right? You got to compare the signs of the velocity and the acceleration, and since they're different signs, this is actually slowing down. Okay? Total distance traveled by particle p. What do you do there?
Absolute value.
Yeah, it's the integral from 0 to pi of d p t dt, absolute value, that, right? So on your calculator, this is just math 9, the integral from 0 to pi, math, number, absolute value, variables, y variables, function 1, dx, that number. Okay?
Well, this was a nice year's one.
Yeah, I like this
It was what?
This one was a nice.
This
This is a nice one.
Yeah, I think this is pretty straightforward.
Let's do the next.
Looking at it, I don't know if there's anything hard about it really at all, other than the notation. The notation's a little like clunky,
Yeah.
but I mean, it's doable. It's not like that confusing, but I could see them possibly like not giving you full credit if you didn't give subscripts and things like that. So you have to be careful about that. You have to make sure that what you're writing is actually mathematically accurate. Even if you know what you're talking about, they're not going to assume you know what you're talking about unless you prove it on paper. So you have to be careful about that. Do I have time for the next one? Should I start it? You guys are like,
I should look,
You're scaring me.
Look at it.
Yeah, it took me like a good portion before we did.
I skipped it. I'm looking back to the last.
No, yeah, it didn't take me long at all except for question.
all right. So we have, I mean, at first glance, it's just an area of volume problem.
Yeah,
First
nice reading.
So this function is y equals, oh, this is why it's just cx radical 4 minus x squared. They don't tell you what c is, so that's a little bit confusing. What's this x value? 2. So that's an important observation to make. You probably need it throughout this problem. That number is 2. You can just set this equal to 0 and find that number. Right? Okay, so part A says find the area if c is 6. So that's just the integral from 0 to 2 of 6x radical 4 minus x squared dx. And this is not a calculator question, so how do you do that? Yeah, this is a straight up u substitution. U is 4 minus x squared. Du is 2x, negative 2x dx. So dx is negative du over 2x. So this ends up being the integral from 0 to 2 of 6x times u to the half times negative du over 2x. So this is a little bit complicated for a free response question having a u substitution like this, but it's not crazy. So those cancel to be a 3, and then there's a negative. So this is really negative 3 integral of u to the half du. You could change the limits of integration and then do it that way, or you could do it the way that I'm doing it here, which would be, this is just negative 3 u to the 3 halves times 2/3. So those cancel. So this is negative 2 u to the 3 halves, and u is this, 4 minus x squared to the 3 halves from 0 to 2. So if you substitute in 2, you get negative 2 times 0 to the 3 halves. And if you plug in 0, you get negative 2 times 4 to the 3 halves. That part's 0. This part is positive. 2 times 4 to the 3 halves is 8. The answer is 16.
But since it's not a calculator, you could have left it as.
You could have left it at this point. No place sooner, though.
Right.
Yeah. Okay?
Oh,
So try B.
Yeah.
oh, gee.
So they're giving you the derivative. Again, the reason why they do that is because they don't want people to mess that up and then be screwed for the rest of the problem. So they're giving you the derivative here. You could verify that if you wanted to, but that would be a total waste of time. So dy dx equals c times 4 minus 2x squared over the square root of 4 minus x squared. And it says the radius of the largest cross-sectional circular slice is 1.2. So they're saying that, if you look at this picture, they're saying that this distance is 1.2 for some value of c. And they want to know what's the value of c. So what do you need to do? Exactly. You set this equal to 0 to find out where that maximum occurs in terms of an x value. So that occurs at when 4 minus 2x squared equals 0. So when 4 equals 2x squared, or when x equals radical 2. So at x equals, they're telling you when x equals radical 2, the height of the function is that. So you just say y of radical 2, which is c times radical 2 times the square root of 4 minus radical 2 squared. They're saying that that has to equal 1.2. Solve for c. Just divide by that stuff. That's all there is to that. This is 4 minus 2, so it's you get 2c equals 1.2, and c equals 1.2 divided by 2. That's it.
I got that one.
That wasn't too crazy.
Number 3 as well.
Number 3, it says for another spinning toy, the volume is 2 pi. So these would be definitely disks, right? So the volume of this thing would be the integral from 0 to 2 of 2 pi, of pi r squared. So it's pi times cx radical 4 minus x squared, right? Pi r squared equals 2 pi. Solve for c, right?
Yeah.
So this actually works out pretty nicely. It looks like you have pi integral from 0 to 2. If you square this, you get c squared x squared times 4 minus x squared, which you could just distribute that and make a polynomial.
Yeah.
This would be the integral of 4c squared x squared, bless you, minus c squared x to the 4th. So when you integrate that, you get pi times 4c squared x cubed over 3 minus c squared x to the 5th over 5 from 0 to 2. You just plug in 2, plug in 0, which is just going to give you 0. So if I plug in 2, I get pi times 32c squared over 3 minus 32c squared over 5. And that has to equal 2 pi. So just divide, no, you can't divide, but you can combine these because they're like terms, they both have c squared, and then just do algebra. Solve for c. The algebra is a little complicated, but this problem wasn't that bad, I didn't think. And I bet if you just set it up, if you just did this, that's probably most of the credit. Okay? Awesome. So we got to do 3 problems. We'll do the other 3 on Monday.
In 40 minutes.
And then we can get back to games. Doesn't calculus look complicated? Look at this.
Is it easier than it looks?
After you learn it.
Okay, that makes me feel a little better. I'm looking at this and like I don't even know where to start. Like,
Yeah.
there's a whole lot of letters, and then all of a sudden there's a number at the end.
Well, we use calculator for a lot of stuff. But you do weird stuff like this on the calculator. A little different.
Just one.
Yes, of course.
Okay, let's do that.
With that class, there's 11 people. I bet there's probably 9 people that got 5s and 2 people that got 4s. That's my guess. Yeah. Wow.
What?
The AP class issue is outstanding.
That's always good.
Yeah.
I feel like the day should have been over a while ago.
I don't.
But at least Sadie, do you have any ideas for the project?
I'm not. You don't want
The video?
to. Yeah, I'm there.
What are you gonna do?
I'm gonna do like